Okay, today we're going to talk about momentum and impulse, which are quantities of motion. They involve things moving. So we're going to define momentum, we're going to calculate momentum, then we're going to define impulse, then we're going to calculate the impulse applied to an object. So those are the four things we want to get done out of this. Momentum is really a measurement of the motion of something. So if a car speeds to you at 27 meters per second, can you stop it by holding your hand out? No. So momentum really measures how hard it is to stop an object, kind of in simple terms. It is a vector quantity, direction does matter, and the symbol is lowercase p. And the units are going to be kilograms times meters divided by seconds, or newtons times seconds. So it's reduced down to the same thing. So P is equal to M times V. That's momentum. So sample number one. Two trains, Big Red and Little Blue, have the same velocity. Big Red has twice the mass of Little Blue. How do their momentum compare? Well, let's take a look at red first. Well, we know that P is equal to M times V, but they tell us that Big Red has twice the mass of Little Blue, so it equals to 2 times the mass of Little Blue times V. So let's take a look at blue. Now blue, on the other hand, P is equal to M times V. They both have the same velocity, and blue has the mass, so therefore Big Red has twice the momentum of Little Blue. Okay, momentum of an object is 64 kilogram meters per second. If the velocity is doubled, the new momentum will be what? Well, momentum is mass times velocity. So you had a total momentum of 64 kilograms per second, and all you did was double the velocity. You're going to have twice the momentum. So therefore the answer is 128. A red cross plane, 3,600 kilograms, is flying at a velocity of 85 meters per second. What is the momentum? Well, P is equal to M times V, so kind of a straightforward plug and chug problem. So 3,600 kilograms times 85 meters per second is 360,000. Now let's take a look at our units. I have kilograms times meters divided by seconds, and nothing cancels out, so that's the way it looks. Now after it drops its care package, that's a typo, the new mass should be 3,000 kilograms, and it flies at 120 meters per second. What is the new momentum? Well, P is again M times V, except now our mass is 3,000 kilograms. It lost the care package, and the velocity, it's actually sped up. It's now going at 120 meters per second. So therefore, the new momentum is 360,000 kilogram meters per second. So what is the change in momentum? What is delta P? Delta P is nothing more than P final minus P initial. Well, we've got both of those from the previous problem. So P final is 360,000 kilogram meters per second, and P initial is 306,000, so the difference is 54,000 kilogram meters per second. That's the change in momentum. So it actually sped up after it dropped the package. And you can think of other cases probably where that would happen. If you're running along, let's say you're walking with your little brother sitting on your shoulders. If he jumps off your little shoulders, you can pick up quite a bit of speed, so your momentum could actually increase. Now, impulse. So as you observed in the previous problem, momentum can change. A change in momentum is known as an impulse, and for impulse we're going to use the letter J. So J is equal to delta P. So the red cross plane comes to a halt on the ground. In other words, it lands. What impulse is applied? So J is equal to delta P. So J is equal to P final minus P initial. Now if you land an airplane, what's the final velocity going to be? Ding, 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 0. So therefore your final momentum is 0. The nice thing about momentum, anytime you have a velocity of 0, you have a momentum of 0. Minus the 360,000 units of momentum you had before, so the impulse is negative 360,000 kilogram meters per second. Remember, impulse and momentum are both vector quantities, so therefore direction matters, so the negative is important. 6 kilogram block sliding east at 5 meters per second on a frictionless surface hits an obstacle. The obstacle exerts an impulse of 10 newton seconds to the west on the block. What is the final speed of the block? Now, first of all, let's without doing any math, let's think about, should the speed go up or should the speed go down? If you're sliding east and a force is applied to the west, it should slow down. So we should expect an answer of less than 5. Let's do the math and see what happens. So we know that J is equal to delta P. Now remember, the block is sliding to the east, and I'm going to call that direction east, but the force is acting back to the west. So since the force is acting back to the west, the force is going to be negative. So that 10 newton seconds is actually a negative impulse. It's slowing the object down. That's equal to mvf minus vi. Now, so negative 10 newton seconds, I'm going to expand the mvf and mvi to make the math easier. Remember, do algebra as long as possible before you put all your numbers in. Negative 10 newtons per second plus mvi, when I move it to the other side, is equal to mvf, because ultimately I'm looking for vf. Okay, now I plug and chug. Negative 10 newtons second plus m, 6 kilograms, times 5 meters per second is 30 newton seconds, is equal to 6 kilograms times vf. So therefore negative 10 plus 30 is 20, so I have 20 divided by 6, which is 3.3 meters per second. Hope that helps.